Assalamu alaikum, hi friends. Today we will discuss about PIC microcontroller and how can we use in embedded system. So, first of all, we will discuss about PIC architecture and their assembly programming language. So, there are some main topics we will discuss in this lecture. The first one is WRE registers, the PIC file registers, and how the instruction with the default access banks. So the book mentioned in this slides, you can also read from this book of chapter number 2. So these are the outlines we will discuss today. First one is a PIC status register, the second one is a PIC data format and their directives, and the third one is intro to the PIC assembly language. Fourth one is assembly and linking a PIC program. Another one is the program counter, and program ROM space in the PIC. And the second last one is RISC architecture in the PIC. And we will view registers and memory with MPLAB simulator also. So these are the objectives which are elaborated. So first one is WRE registers. So WRE register, working register, is one of the most widely used of the register of the PIC. It's a 8-bit register, and data maybe if it's will be larger than 8-bit, so it will be broken into the different chunks. And so for example, we use 12-bit data. So firstly 8-bit data will be processed, and then after 4-bit will be execute one by one, like in sequence. The next statement is move LW. It's move 8-bit data into WRE registers, and its examples are some examples are given, and you can also perform it and check it which one is code is correct, and what's are some problem in it. So in next one, this examples add LW with literal value of k in W reg registers, and there are some examples given of this type. And the next one's topic is PIC file registers. So PIC file registers, there are main two types. First one is general purpose RAMs, and second one is special function register. In general purpose registers, RAMs, another one is GP RAM, and the second one is double EPROM. It's data in memory, like read or write data with like in the phenomena of statically RAM. So it's used for data storage and scratching by using internal function. It may be 8-bit. There is some internal structure of register concepts in which you see that from left side there's a ALU unit, and then it will move from data bus, and then it will recirculate from WRE registers and then go to in decoding site. So register files are like it's a concepts of data memory is a part of register file. So any location in the data memory may be operated on directly. So peripherals are mapped into data memory or series of registers. Special function registers. These are the function of each SFR is fixed by the CPU designers at the time of designing. So when a designer make a processor, there are some selections before finalizing the processor. So it is used for the control of microcontroller or peripheral which are attached with the controller. So it is dedicated to the specific functions such as like ALU status, timer, serial communications, IO ports, and ADC. SFR these are 8-bit registers. Their number vary from one chip to another chip. General purpose RAM, group of RAM locations like these are 8 bits. These are larger than SFR. Special function register, so it is difficult to manage them by using assembly language. Also these are easy to handle by using C compiler. The microchip website provides a data RAM size which is the size of GPR size. File register size, there are different types of controller PIC, and showing their file register size. their SFR size and GPR size. So there is a decision when we make a controller. For that purpose, we decide like pick 12F508. Their file register size is 32 bits, and SFR size is 7 bit, and GPR size is 25 bit. There is some graphical representation of the PIC registers like PIC 12, PIC 16, and PIC 18. The left one is PIC 12, and you see that their SFR size and GPRM, and the second one is PIC 16, and third one is PIC 18. So you see that the size of RAM is changing from side by side. PIC register and their SS bank in the PIC 18. The PIC family have a maximum of 4096 bytes. So the file registers have addresses of 0002 from this location to this location, and divided into different types of banks like 256 bytes of banks and maximum of 16 banks. So how it is possible? At least there is one bank which is known as a default SS bank. So bank switching is a method used to access all the banks. In PIC 18, you see that in previous slides it has 256 bytes banks, so divided into two discontinuous sections, like each has 128 bytes. So GP RAM from 0 to 7F this location, and SFR special function register from this memory location to this location as given in slides. So using instruction with the default SS bank, we need instructions to access other location in the file registers for ALU and the other operation. Like some examples are given: move WF, com F, decrement F, move F, and move double F. Move WF instructions have F indicates for a file registers. Move WF this address. It tells the CPU to copy the source register, then WREG to a destination in the file register. So A is location in the SFR and is a location in the GPR name, which is given in the figure. This example is a simple example which tells us how data save from one location to another location, and then how it will move. So in this example we practice of different tasks which are discussed in previous slides. So there is a mode. We cannot move literal values directly into the general purpose RAM location in the PIC 18. So there is a limitation of a PIC 18. So they must be moved there by using a WREG registers. Add WF. There is another statement. Add together the contents of WREG and a file register location, like add WF register dot address D. This result will be placed in either the WREG or in the file register location. So what will indicate D? It tells us destination bit. So if there are some check, if the value of D is equal to 0 or the value of D is equal to W, the result will be placed in the register. If D is equal to 1 or D is equal to F, the result will be placed in the file register. There is another example. Statement is given that the content of the file register location and the W register after the following program, in which step by step we will discuss. These examples are also for practice purpose, so you will be performed on your compiler. There are some block instructions of WREG file register and ALU in the PIC 18. This is a model of PIC 18 in which you see that WREG registers and this so it is 18-bit instruction words, and it will come from goes to ALU, then it will there are some status and it's some register files and some special function registers and general purpose RAM location. So you mean to say that it is a structure of a PIC 18. COMF instructions. COMF file register, it tells the CPU to complement the content of file register and places the result in the file or registers. There is another example in which simple write a program to toggle the SFR of a port B continues to forever. Decrement function instructions, it tells the CPU to decrement the content of file register and place the result in the given register. In this example, you see that it will be decrement and then store the result in any file. Like you see that movef instructions. It is also intended to perform some function like there is some condition. If d is equal to 0, then it will copy the content, or it will be condition will be changed, then it will not copy the contents. Movef instruction is also using for moving the value of. In this example, you see that there is another simple program to get data from the SFR of port B and send it to the SFRs of port C continuously. Another example is we make a program to get data from SFRs of port B and then add the value F to it and send it to SFR of port C. These are some simple programs. You can compile it and then burn into your controller, and you will see their outputs. Movef instructions, it's copy data from one location in file reg to another location which are given. There is another example. Their statement is write a simple program to get data from SFR of port B and send it to the SFRs of port C continuously. PIC Status Register. These tells about the status of the registers. Also, it indicates some conditions like different function, arithmetic functions. So these are 8-bit registers. Also, we will use 5 bits are using like carry flag, digital carry flags, 0 flags, overflow flag, negative flags. So there are some format of status registers: carry flag, digital carry flag, 0 flag, over flag, negative flags. So in this example, show the status of the different flags after the following addition instruction. So after this instruction, what will be the status of the these flag, like carry flag, digital carry flag, and 0 flag. So you will run this program in your compiler, and you will see the results. There is another example in which you also perform the task of addition and then see the status of these flags. There are different flags and what will be effects on the bits. You see in this table. There is another table which these are tables are taken from books which mentioned in the first slide. You can also for extra study you read from these books. These are another instruction flags and their bits and how it will affect on the different bits. Like flag bits, there are some another bits, decision making bits, flags which use like branch relative if carry, and BNC, BOV. These are different types of flags which are used for decision purpose. PIC data format in last we also discussed, it will be 8-byte. So data formats are like in hexa, in binary form, in decimal form, in ASCII form. So we will convert into desired or required form. There are some assembler directives. So what is the difference between instructions and directives? It defines constraints or fixed addresses. So set, it defines constant or fixed addresses. It may be reassigned later. There are some directives mentioned in last. Rules for labeling in assembly language. The first one is the name will be unique. Different alphabetic letters, upper cases, lower cases, digits, special characters. So the first letter must be alphabetic letters, not reserve a word. The main thing we are starting is now introduction to PIC assembly language. It will be difficult for us to deal the machine language like in the form of 0 ones. So assembly language provides mnemonics like codes and their abbreviation that are easy to remember. It faster programming and less prone error, and it's also known about all registers. Assembler is used to translate the assembly code into machine code, which is like object code. Structure of assembly language. There are series of lines like instruction directives. It consists of 4 fields. First one is label, then mnemonics, then operands, and then commands. Commands mean what we want to perform, like addition, subtraction, multiplication, move, any one. Labeling. It refers to line by line code like certain lengths. Mnemonics and operands are tasks that should be executed, like addition, multiplication, and etc. Directive don't generate any machine code and used by the assembler. There are some simple assembly language program we are discussing. There is a program of like assembly language. You can also see that on your screen. There's some left side from mnemonics, and then their operand codes, and then what you want to perform on it. So you will be performing your assembler, and you will see what will be its results. So assembling and linking of a PIC programming. First one is like editor program. Its extension is different, like myfiles.asm. Then assembler program. Assembler program extension is different, and then it will be recompiled like into linker program. And linker program, it's a different types of extension which will be used for the controller or ROM, like different their formats in hex files, different types of files which are mentioned in these slides. So this is a interface of a micro C. So how can it will work? In left side you see that it's values, and then its location, and after that you see that how this instruction will operate like one by one. The program counter and the program ROM space in the PIC. So the program counter is used by the CPU to point to the address of the next instruction to be executed. The wider the program counter, the more location can be accessed. So PIC 16 has normally 16 KB memory, PIC 18 has 2 MB, and 8051 has 16 bits and 64K memory. So in this example, find the ROM memory addresses of each following PIC chips, like PIC 18 F22 2220, PIC 18 F2410, and the last one. So in this figure you see that how can we calculate the memory addresses. So powering up. At what address does the CPU wake up when the power applied? The microcontroller wake up at the memory address means that when we supply the microcontroller, it will wake up and ready for the working. There's some another interface of micro C in which you see that how the memory of ROM will be working. ROM width of microcontroller, like PIC 18, its CPU of 8-bit fetch 1 by 1 memory instruction 1 by 1. Increasing the data bus will bring more information. So what will be the solution? The data bus between CPU and ROM can be similar to the traffic lanes on the highway. So this example tells us the width of the data path is 16-bit, so increase the processing power and the match the PIC instructions single cycle. There is another thing important, RISC architecture in the PICs. RISC abbreviation stand for reduce instructions sets. See, I didn't tell you, you will also see. To increase the processing power of the CPU, increase the clock frequency of the chip, use Harvard architecture. So change the internal architecture of the CPU and use what is called RISC architecture. RISC architecture in the PIC. RISC, it's a simple and small instruction set. CISC, it's a complex and large instruction sets. Regular and fixed instruction formats. RISC is simple addresses mode, pipeline instructions, execution 90% execute in one cycle, and CAC, complex instructions set cycle. It's a complex addresses modes, may also different pipelines, more time will be required. And RISC also provide large number of CPU registers. It separated data and program memory. Most operations are register to register, take shorter time to design and debug, and CAC provides smaller number of CPU registers, combine data and program memories. Also, most operation can be registered to memory, take longer time to design and debug. This is also the continued lecture of previous lectures, and these topics are mentioned in the chapter 3 of PIC controller and embedded system Muhammad Ali Mazidi book. These are some topics which we will discuss, like branch instruction, call time and delay loop. So branch instruction and their looping, call instruction and stacking, and PIC's time delay and their pipelines. There's some objective we will discuss, like branch instructions, looping, and go to instructions and unconditional jumping. And branch instructions like looping in the PIC, looping inside the PIC, conditional jumps, branches and short jumps, and their addresses and their instructions. Looping in PIC. That there are two ways of looping: by using decrement FSZ instructions, using BNZ/BZ instruction. Decrement FSZ instruction, it's a decrement file register, skip the next instruction if the result is equal to 0. The second one is a decrement FSZ file, then go to instructions, and from right side there is some flow charting that how this instruction will work. There is example of simple data program in which clear W register, then add to the 10 times and place the result in port B. In the right side you see their solution, that how it will work from step by step. And there is a flow chart of previous example, that how this statement will be operated. B and Z slash BZ instructions, these instructions supported in PIC 18 family and also in PIC 16 and PIC 12. These some instruction doesn't support it. There is another examples in which same task will perform. In example 3, there is a example for home task. What is the maximum number of times that a loop can be repeated? All locations in the file register 8-bit. The maximum loop size is 255 times. So another topic is a loop inside a loop. So this is a program in which we will load a port B SFR register with the value 55H, then complement port B 7 times. The solution is given, and it's work one by one, line by line, and their output will be given from in the right side for your easiness. Other conditional jumps, all of the 10 conditional jumps are 2 bytes instructions. In the BZ instruction, the Z flag is checked. If it is high, that is equal to 1, it jumps to the target address. These are also some flag bits and decision makings which we are discussing in last lectures. And there is another example. In example, what we will do: write a program to determine if the LOC, like this address, contains the value 0. If so, then put 55H in it. So how can we replace this value? It's mentioned in later. In example 6, for your information purpose, find the sum of the values of these numbers and then put the sum in the file of this location. So there is a solution of this example. So the first thing is that you will work by your own your mind, and then see this solution. The solution is given of these examples. So there is another question: which one is better to use? If you solve this example manually and you search this, then you will give the answer of this equation. Which one is better? You will also search about a BNZ instruction, decrement, and the third one instruction. Then you will able to tell which one is more better. Unconditional branch instructions, these are go to and BR instructions. BR instructions, their formats and how it will work, and their syntax is given. This is the interface of micro C, in which branch instruction how it will work from forward and from backward. Go to itself a label and can be used to keep a micro C busy. Jump from same location here to go here, go to. These are the some syntax which tell us about go to in micro C. PIC 18 call instruction. These are section in the book of 3.2. You can also read it from book. Call instruction. These are the call a subroutine, like calling a 4-byte instruction long call or 2-byte instruction a relative call. There is a call instructions. There format of a program counter, which will be 21 bits counter, and there is spacing from 0 to 5 times f. Call instruction is transferred to the subroutine. Current PC value of the instruction addresses just below the call instruction and is stored in the stack, push onto the stack. So return instruction is used to transfer the control back of the caller. The previous PC is popped from the stack. Stack and stack pointer. Read or write memory like RAM used by the CPU. It stores the PC addresses from this location to this. 5-bit stack pointer at a different location like 32, and it's contain 21 bits long. Stack points to the last choose location of the this. These are the structure of the PIC stack, whose sizing 31 by 21. Return from subroutine. The stack is popped and the top of the stack is loaded into the program counter. In this example, we will toggle all the bits of special function registers to the port B by sending its value 55H and AAH. Continuously put a delay in between issuing of data of port B. So by analyzing the stack for the call instruction, there is a solution of this example. Try to solve it yourself and then compare it with the solution. The solution is example in micro C mode. You see that their assembly micro C, and the second one is a recall relative call. It's a 2-byte instruction. The target address is must be within the 2K, like 11 bits of 2 bytes is used. There is an interface of micro C, that how it will be operated of this. This is the code of the micro C of example number 3.12, which we discussed in previous slides. PIC 18, we are discussing PIC 18, and now we will discussing their time delay and instruction pipelining. Their delay of PIC 18, there are two factors. The first one, the duration of the clock period, and the second one is instructions cycle duration. So most of the PIC 18 instructions consume one cycle, like different architecture, RIC, Howard architecture. PIC multi-staging pipelining, which will be used if instructions are increasing and spacing is less, then multiple pipelining is used to reduces the steps. So these are their internal structures in which pipelining activity of and their fetching and execution of PIC 18 controller. Instruction cycles and their times for the PIC. So what is an instruction cycle? Most instructions take 1 to 2 cycles. Instruction cycle depends on the frequency of the oscillator, clock source, crystal oscillator, and on chip circuitry. So one instruction cycle consists of 4 oscillator periods. In this example, simple is that find the period of instruction cycle. You choose 4 MHz crystal. Their solution is simple is given, that is f is equal to 1 over t. In this example also find how long it takes to execute each of the following instruction for a PIC 18 with 4 MHz cycle. There are simple assembly language code, and output will be simple. And this example, find the size of the delay in the following program of crystal of 4 MHz. There is a simple assembly code, and its result will be shown. You will also perform these examples on your compiler and check what will be the results. So there is summary of the chapter is that looping, loop inside loop, and programming language, their conditional statements, and their pipelining, and speed of the PIC 18.